Okay, in this video we're going to be looking again at complex numbers. We're going to be looking at quadratic equations. Okay, so we've seen quadratic equations before. They're generally going to be in the form ax squared plus bx plus c is equal to 0. Okay, where a, b, and c are going to be numbers, and we have x squared, an x part, and then just a constant. The formula we generally use to find the solutions or the roots is going to be, let me get rid of that, x is equal to minus b plus or minus square root b squared minus 4ac over 2a. Okay, so the quadratic formula, yeah? And we know, so if we look at this part here, b squared minus 4ac, okay, if b squared minus 4ac is less than 0, or in other words, if it's negative, yeah, then we're going to have a problem, because, let me spread that a little bit more, I use blue. If b squared minus 4ac is negative, and we have, in the square root, we have the square root of a negative number. Okay, and this is why b squared minus 4ac is called the discriminant, because it tells us the nature of the roots. Basically, it tells us what kind of roots this quadratic formula will have, or what kind of, if I do a quick x, those are the roots. So is it going to hit the x-axis? Is it not? Is it going to hit it once? The b squared minus 4ac tells us all of that just on its own. Okay, that's what's called the discriminant. So back to this, if b squared minus 4ac is negative, or if it's less than 0, that means we have the square root of a negative number, and we know that that is a complex number. Yeah, because we can't get the square root of a negative number, so we're going to have to bring in I, the imaginary number, the complex number, so we're going to have a complex number, okay? And if it's a complex number, that means the quadratic equation, this one here, is going to have complex roots. Okay, it basically means that it won't hit the x-axis, that the u is going to look something like that. Yeah, and we're going to look at what the roots look like. We're going to get them in a different form. Okay, so we couldn't do those before, but now with this chapter we can do we can find complex roots as well as normal roots for quadratic equations. Okay, the complex roots are going to be in the form z is equal to a plus or minus bi. So basically, you'll see what that means now in a second. There's going to be two roots. It's going to be a plus bi and it's going to be a minus bi. Okay, so we'll go ahead with an example. So for quadratic equations in algebra, it's normally x squared plus x and so on and so on. When we're doing them in complex numbers, they're generally going to be, let me just erase this, give the pen back, it's generally in the form z squared. Okay, so they use z, and if you see an equation with z squared in it, you generally know it's going to be a complex number. Okay, so z squared minus 6z plus, give me 1 second, plus 13 is equal to 0. Yeah, okay, so they told us to find the complex roots of this equation here. So no point factorizing it, because we know there's not going to be any, there aren't going to be any factors. We're going to have to go straight to the formula. So we're going to say z is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so if you need help using this formula, we have another video on how to use the quadratic formula. So I'm just going to go straight ahead. So we know that this is going to be b, this is c, and this is a. So z is equal to, it's going to be plus 6, because minus minus 6, plus or minus the square root. So it's going to be minus, let me get rid of that. Okay, now I'm going to have to erase it. And bear with me. Okay, sorry, so minus 6 squared minus 4 by 1 by c, which is plus 13. All divided by 2a, which is just 2. Okay, oh, I ran out of space. Sorry, I keep doing this. I will draw a line down here and hopefully be able to squeeze it in. Okay, so that means that z is going to be equal to 6 plus or minus, so the square root of 36 minus 52, I think. Yeah, square root is 36 minus 52, all divided by 2. So that means z is going to give us 6 plus or minus the square root of minus 16 over 2. Z is going to give us 6 plus or minus 4i. So if we want to break that up, we're going to break it up into the square root of minus 1 by the square root of 16. And that's going to give us this thing here, divided by 2. And the last line, or the answer basically, I'm going to do it in red. So Z is going to be equal to 3 plus 2i. So 2 into 6 is going to be 3, and 2 into 4 is going to be 2i. And then Z is going to be equal to 3 minus 2i. Because it's plus or minus, there's going to be two cases. So we're going to have 3 plus 2i and 3 minus 2i. And those are our two complex roots. I'm going to draw a little box around them just to say there's our answer. Yeah, so that's it basically. So that means they don't hit the x-axis at all. So they're just the kind of the roots. So we'll talk about Argand diagrams and what these kind of mean there. But just for now, that's all you need to know. So that's what I meant when I said as well, the complex roots are going to be 6 plus or minus bi. It's going to be the same thing, but there's going to be a minus in between them. Okay, I hope this video helped and enjoy your day.